All right. Good morning, everybody. Welcome back to Comp 2450, Software Development 1. I hope that you are all doing okay today. Today, what I want to have us keep working on is design by contract. Last class, what we did was start introducing the idea of a class invariant. And I want to review what we talked about last class because I want to ask you to do it for me today. So I want to show you what we went through in terms of class invariants for some of the things that we were thinking about. And then I'm going to ask you the same question. Tell me what the class invariants are for a different class. So we can have a couple of classes that have these class invariants. Doing that is half of the exercise. I want to think about what these class invariants are. And then what we're going to do is actually start enforcing them. And so we're going to do that in a couple of different ways. So by the end of today's lecture, what I want you to be able to do is I want you to be able to define the class invariants that encapsulate the valid state of an abstract data type. Like I said, I asserted these to you. I told you what they were last time. I'm going to tell you again what I think they are for this thing, and I want you to tell me what those things are this time. I want you to be able to use preconditions, postconditions, and invariants to validate the runtime behavior of an abstract data type being used in an application. So we're going to be defining class invariants for our classes. And the word precondition and postcondition here, the way that we're going to be using those is to effectively say where in a method we're going to call our class invariant. We're gonna write a method to do this for us, and we're gonna decide where to call that based on this. Preconditions and postconditions are gonna come back later when we're starting to think about implementing functionality that we have for our applications. But in terms of class invariants, this is really just saying where we're calling this class invariant in the code that we've got right now. The other thing I want you to be able to do is to continue to be able to use an automated build tool to build a complex project. And the way that we're going to do that today is I want you to be able to add a dependency to your project. Java does have built-in support for some of the stuff that we're doing, but it is kind of painful to use and kind of awkward to use because you have to oh gosh, you got to pass flags to the JVM. So when you start the Java command, you have to tell it to do a certain thing. And that's really awkward and painful when you're using an IDE. It's possible. Don't get me wrong, it's possible, but it's really awkward and painful when you're using an IDE. It is even more awkward and painful when you're also using a separate build tool like we are with Maven. And so we're going to use a different library to help us with this. And I'll tell you a little bit more about that when we get to that point. So the first thing I want to do is I want to start reviewing the idea of design by contract really, really quickly. The idea here is that this is code that we, you, me, we are going to write that's encoding the assumptions about the input, outputs, and the state of the software that we've got. When we started doing domain modeling, one of the things I was asking you to do was start writing these things out as these non-technical terms that describe some of the ideas related to what is valid for this thing to be. And that was to front load this a little bit. I wanted you to start thinking about what those things were so that when we get to the point of actually writing code in Java, where the type system that we have in Java can't really enforce those things for us, that we have an idea of what those assumptions are so that we can actually write the code to enforce those things. We're focusing on this idea of a class invariant. Class invariants are going to be, as you might expect, attached to a class. And the idea here is that we are trying to validate the valid states or values of all properties in a class instance as appropriate. So if there are assumptions that we have about what a value in a class should be at runtime, before we start working on something and after we have finished working on something, then this is the place that we're going to be putting those things. These are technical. Null, when appropriate, primitive types in Java cannot be null, but null, when appropriate, is almost always an invalid state in Java. This is not a universal truth. There are places where it's appropriate for null to be an actual value for something, but in a lot of cases, especially with the stuff that we're looking at now, null is almost always an invalid state. One thing I want to remind you about here is that we are explicitly not doing input validation here. I'm not trying to protect against my parents. They've got a keyboard. I'm getting input from them from scanner.in, but I am not actually system.in using scanner, but I'm not actually protecting against that right here. I'm trying to protect against me. I'm trying to protect against you. I'm trying to protect against myself, and I'm trying to make sure that when this method is called, when this class instance is used, that it is a valid state in terms of what we can do as developers. And so that null keyword shows up. I want to make sure that something is not null because my parents can't type in the word null. I want to make sure that a value is positive. My parents can enter negative values. Sometimes these things overlap, but we're really just trying to protect against ourselves and other software folks here. So I'm going to quickly come back to this. But what I want to show you is the state diagram that we've got right now in terms of our trainer here. So when you're doing this for your own projects, I'm going to be expecting you to document the invariants of your own classes in your class diagram, kind of like what I've done here. So I've got this trainer. We've got a couple of properties that are not primitive types in Java. So these are lists. We have a type that kind of is a primitive type in Java, but can be null, which is a name. We have this thing that's called a balance here. What I asserted to you on Monday about these properties is that things that are not primitives in the context of this trainer class should not be null. The team should be a list that's initialized. The inventory should be a list that's initialized. So it must be not null. I must have at some point said is equal to new array list or new linked list or something like that. I must have initialized this to something. I told you a little bit about something that I know about Pokemon, which is that when you have a set of Pokemon on your team, you have to have one. You must have one Pokemon. So there's two properties about this list that must be true. One is that it shouldn't be null, and it has to be at least one in size. I must have at least one Pokemon on my team. Inventory must not be null, but I don't have to have anything. I think when the game starts, you don't even have the town map yet. There's nothing in your inventory to show up. Do you have a question? Okay. There's nothing in your inventory, and that's an okay state to be in. But what I want to say here is you should have an empty list then, so that when you add something to that list, you're not going to get a null pointer exception. Yeah. I guess that's technically true, but you cannot leave Pallet Town until you have a Pokemon. Yeah, fair enough. Fair enough. Now we're getting into like the depths of the arcane things related to Pokemon. I'm going to say you can't leave Pallet Town without. Yeah, okay, fair. The other thing I said here is that our name must not be null, and we must have at least one character in our name. So string as a primitive type in Java is not really primitive. It can be assigned null. In a constructor, I could say name is equal to null. I may have a mutator that says I'm changing my name to null, and I want to prevent you from doing that. But I also want to say that when it's not null, you have at least one character in your name, at least one symbol that represents what your name is. The other thing that I've got here is balance. And in terms of whatever you've got for money in Pokemon, you must have at least some money or zero, but you're not going into debt. This isn't Animal Crossing where Tom Nook is constantly putting you into debt to try and get you a bigger and bigger house. That game, gosh. My kids love Animal Crossing, and that's awesome, I guess. But like, I feel like it gives them the wrong idea of the way that we should be living our life, where we're just constantly in debt to, what are they, raccoons? Are they raccoons? Yeah, I think so. Yeah. Okay, so I want to ask you the same question here about Pokemon. I want to leave this up. I want to leave this up as it is right now for about 30 seconds so that you can have a chance to look at it on the big screen. Then I'm going to pop over to my slides to show you the QR code, and it will still have this thing. And then I'm going to switch to Mentimeter. And what I'm going to ask you to show me in Mentimeter, in the responses that you're giving me, is one moment. I want you to give me Boolean expressions that look like this. I don't care about the difference between size and length. I'm just going to assume that they mean the same thing in the context of both things. That's as an implementation detail that I want to worry about later. But what I want to see are Boolean expressions. These are simple expressions that demonstrate an assumption that we might have about this property. So I'll hold this up here for 30 seconds. All right, I'm going to switch to my slides that's got the QR code, so you can join the Mentimeter. I'll hold this up here for about 10 seconds, and then I'm going to switch to Mentimeter. Okay. Awesome. So we've got lots of stuff here right away. I'm going to take some of these and I'm going to start putting them into this class diagram because I want to encode what we've got here as ideas. So I'm going to bring up Chrome here. I'm going to make it a little bit smaller. I'm going to start writing some of these things in. Oh my gosh. I really love this, but it's giving me AI repair because, gosh, I don't know why. Okay, so note for Pokemon. And what I want to add to Pokemon is that the name is not equal to null. Yes, I believe that this is something that we want. So name or nickname, I see that showing up in a couple of places. So I'm going to say that the invariant for this, one of them is going to be that the name or nickname must not be null. Another one that I see here right away is that the nickname is greater than or equal to 1. I'm going to interpret that to mean that the length of this thing must be greater than or equal to 1. We must assign a nickname to it. So when you're playing the game, when you catch a new Pokemon, you get the chance to give it a different name. And by default, it's given the name that it has as its Pokemon type. So when we're doing this, it kind of must have a name. And so I'm going to say that, yes, this is definitely a true thing. So the nickname dot size or length is greater than 1, greater than 0. And this was set as greater than or equal to 1. For the record, if you are asked to do something like this on a quiz, for example, I'm not going to judge you on the differences between size and length. I can't even tell the difference between size and length. I just want to see that you know like what we're asking about here. Okay, so type.instance of Pokemon type. So I'm going to go back here to type, Pokemon type. That is an excellent thing to bring up. I really like the idea that someone is thinking about this idea. The type property that we've got here on Pokemon is of this type, Pokemon type. Pokemon type here is an enumeration. This is something we've defined, and there are 10 different possible values for this thing. This is actually something that, at least in Java, we don't need to have as part of our class invariant because the compiler is preventing us from putting anything else in there. We can't do something that's not in that enum, with one exception, and I want to point at the thing that is right next to it here. Type can be null. It can be null, and if it's not null, it kind of has to be one of those other enum things that we've got in the type system that we've set up in our enumeration. So what I'm going to say here is that type must not equal null, and that this instance of is an excellent observation to make. I'm really happy that you've made that observation, but our compiler is preventing us from doing this because of the type system that we have in Java. Let's keep taking a look here. So I've got type does not equal null, conditions does not equal null. That's great. Conditions is a list. We've got nicknames is not equal to null. Great. We've got current health is greater than or equal to 0. Good. Our health can't be our health can't be negative. It must be greater than or equal to 0. Yes, we should. Max health I see here is greater than 0. I like that. Stated as not greater than or equal to 0, your Pokemon must have at least 1 hit point as its maximum value. Otherwise, it's never alive, right? So it's never fainted. Pokemon don't die. It's never fainted. So it must have a value that's going to be greater than 0. I'm going to keep scrolling through here and see if I can find what you are saying. The relationship between current health and max health. Right here, I see it. Current health is less than or equal to max health. Yes, that is absolutely something that I want to make sure I've got here. So current health, thank you. Is less than or equal to max health. Okay. I'm going to take a look at a couple of other these things to make sure that we haven't missed anything, but I believe that we have got everything here that I want to capture in this. Thanks, Ray. So same thing with this one. I'm really delighted that you've picked this idea of it must be of this type of this enumeration. So I'm looking over here at this specific thing where we've got a list of Pokemon conditions. And the idea here that's being stated is that it must be an instance of this type. That means to me that, again, the type system that we've got in Java is enforcing this. We're not going to be allowed to add anything to this set that we've got here or a list of conditions that's not in here. We could add null. We could add null. So I'm going to ask the question to you, unless you want to say it, unless you're going to say it. Do you have a question? So the difference between invariants and preconditions here for us for today is that we are going to call our class invariant when we start implementing it as a precondition and as a postcondition. For us for today, precondition and postcondition effectively means where are we putting the method call to this thing to validate our data. Later, we're going to be using preconditions to validate the inputs that have been provided to us by caller, so as arguments to a method. But just for today, we're just thinking about this in terms of I'm going to call this invariant before and I'm going to call this invariant after I've made changes to something. Yeah. Okay. So my question to you is, I've got a list of conditions. The point being made here is that the conditions that are inside of this list must be of this type. I'm saying that our compiler is going to prevent us from adding anything to this list that's not in this enumeration, except for null. It's going to allow that to happen. And so my question to you is, should we be checking the contents of this list to make sure that they are all not null? Quick thumbs up, quick thumbs down. What do we think?
There's a method that we made clear condition, and it turns void. What do you mean by clear condition? Because it will remove all conditions, so that will assign a default value or null?
Clear conditions, what I mean by that is it's going to empty the list. It will make the list into an empty list. It will remove everything from the list. Okay, so thumbs up. We should check to see that all of the things that are in the list are not null. Thumbs down. No, we shouldn't check that. It doesn't matter. Everybody, thumbs up, thumbs down. Or middle, sure, middle. Okay, I'm seeing lots of both and lots of middle. Okay, I'm going to say yes, we should actually check that. I can add null to a list. That's a value that I can type in as a programmer. I can say I want to add null to this list of conditions. That is not a valid condition for this Pokemon to have. A valid condition for this Pokemon to have consists only of the things that are in Pokemon condition. So I am going to write one last thing here. Thank you all for sharing this. This is the last thing I'm going to add to this, and so I want to pop this up here. The very last thing I want to add to this is effectively, I want to have a loop. And the loop that I want to check is that all conditions in the list of conditions are not null. If I have one condition, I want to check to see that that one condition is not null. If I have 10 conditions, I want to make sure that none of those conditions are null. Null is not a valid condition for me to have. So my list may not be equal to null, and all the values that this list currently have should also not be equal to null. None of them should be equal to null. We okay with that? Yeah.
And what we mentioned, like our condition
So this one here, we're referring to, we're referring to the list property itself in the class. This must be at least an empty list. And here what we're saying is if there are elements in the list, if its size is greater than 1, everything that's in that list must not be null. Okay, yeah.
Join multiple of these conditions together. Like for instance, when we say current health is less than or equal to max health, we also say current health is less than or equal to 0. Is that same sentence?
Greater than or equal to? Yes, yeah. So the question is, can we combine these? It boils down, I believe, to can we combine these? And the answer is, yeah, for sure you can combine them. These are Boolean expressions. These are Boolean expressions. And I'm using these Boolean expressions intentionally because we're going to take these Boolean expressions and just drop them into code. With a Boolean expression, we can combine them using and. It's a good idea to put and in places where it makes sense. I don't want to have one giant and block for everything here. For me, it may make sense to say things like nickname is not equal to null and its size is greater than 0. That would be one valid condition. It's also fine to test them separately and kind of say like it should not be null and also it should be as two separate things. We could say that current health must be greater than or equal to 0 and max health must be greater than 0 and current health is less than or equal to max. We can say that as one long and condition. One warning that I would give you about that is that if you have this one really long and condition, when you are actually checking these invariants, it can become difficult to know which one caused this to fail. When we've got null versus size, it's actually hard to tell the difference between null pointer exception and I've made the wrong assumption about something here about the size of the thing that I've got, or the size is not correct. It may be difficult to tell the difference between health is less than 0, current health is less than 0, or current health has exceeded max health if you have these all bound together in one big long statement. Yeah.
So could we write it as, say, 0 less than or equal to current health less than or equal to max health? Like in our note here?
Current less than or equal to, like inverting.
No, like just no and symbol, just 0 less than or equal to current health less than or equal to max health. Like
So making something like a range less than or equal to current health less than or equal to max health.
Yeah.
That's reasonable. Same thing I'm saying about this though. In terms of when we translate this to code, it can become difficult to tell the difference between what those things are. So for me, when I'm thinking about this, I'd much rather be listing these out as individual things as opposed to combining them into one statement. Yeah. All right. Are there any other questions about this? Because what I want to do next is take this and start actually writing some code. Yeah.
Just to clarify, Pokemon condition is a enum, right?
Yes.
Is that possible to enforce in the enum itself, such that entries cannot be null?
So what we're talking about here, this is a good question. The question is ultimately, can we enforce in the enumeration itself that the value that it has is not null? And the answer is kind of no. I'm going to pop over to my editor here for a second, and I'm going to open up this main file. And what I'm going to say is I have Pokemon type here, or Pokemon condition. I can say condition is equal to null, and there's nothing that I can possibly do in the definition of an enum to stop this from happening. I can't prevent me from assigning null to this variable. So the only way that I can really check is in my actual class definition to go through and check, are all the conditions that have been added to this list not equal to null? Yeah. Okay. All right, awesome. Okay. So I'm going to go back to my slides. Thank you all for helping out with this Mentimeter. We've described these class invariants now, but I mean, it's kind of not super useful if it's just in the class diagram. I believe this is important for us being able to communicate between each other and between the people that we were working with originally when we started to use these non-technical terms, what our assumptions about these types are. But now we need to actually take that and put it into code. We're going to take all of these Boolean expressions that we've stated here, and we're going to encode those in a method in our code using something that's called an assertion. Design by contract is not a programming language specific thing. I'm going to show you one way to do it in this class. I want you to do it this way in this class. But it's not a programming language specific thing. And in fact, this word assert shows up in many different programming languages, and it means effectively the same thing. In Python, you have an assert statement. You write the word assert, you put a space, you put a Boolean expression, you put a comma, and then you put a message describing what should be printed out when this assertion fails. The person reading this code, a developer, will look at that message and understand what has failed about this thing. C has an assert function. This is not necessarily part of the language, but it's so common that it's part of the standard library. There is no message. C is a bad programming language. We all want to hate on it. All we can do is assert. We get an assertion failure, and then that's the end of it. In JavaScript, there is console.assert, and it looks very similar to what's in Python. You put a Boolean expression, you put a message that gets printed out to the JavaScript console when you're looking at your page, and then the code stops executing. In all cases, when we hit these assert statements, if the Boolean expression is false, the idea is we stop. We raise an exception. We do not proceed past this point. We are in an invalid state. We're going to stop here. But all programming languages effectively have something like this. All programming languages effectively also have something like this in the form of a conditional statement that throws an exception, but assert is so common among all programming languages that we're just going to use this word assert to describe this idea. Java does have assert statements. There is an assert keyword in Java. It does the same thing as in Python and in JavaScript. You have a Boolean expression and you provide a message, but turning these assertions on in Java is kind of awkward. The reason for that is that by default, these assertions are turned off. And what that means is if you put assert, the Java keyword assert in your code, by default, the JVM will just skip them. It's not even going to try to evaluate these assertions. And that's a reasonable choice to make on the part of Java as a programming language, because these things can become expensive in the long term when you're working on bigger projects, or alternatively, when you're working on projects that are targeting something that is very small in terms of computational power. It's appropriate to want to be able to turn that off, but for us in this course, I don't really want to be able to turn them off. I don't really want to have to pass flags to the JVM in 2 different ways as part of this course. And so instead, what we're going to do is use a library to help us with this. The library that we're going to use to help us with this is called Google Guava. I put links in the course webpage for today's lecture to 2 different Google Guava references. The first one is the main website for Guava. This website looks bare bones. It doesn't really look like a Google-funded website at all to me, but I don't know, it is what it is. Guava is what I would consider to be a very well-established library in the Java ecosystem. This is something that people have been relying on for a long time to kind of fill in some of the gaps that the JVM and the JDK have as a standard library. The other thing that I've linked to is the GitHub page describing preconditions, which is what we're going to use. This is the name of the library, and I want to make sure that we're not confusing the name of the library that we're using with the concept that we're applying. We're going to use methods in this preconditions library to implement our class invariant. We will call this class invariant as part of the code that we're putting in a precondition, but the preconditions library here is kind of what we're going to be using for this. So the very first thing I want to do with this is I want to add Guava to our project. I welcome you to follow along with me if you want to, either with your own project here or with the 2450 Amman example that we have been working on. The way that we're going to add Guava to our project is that I'm going to open up this file pom.xml. This was the file that got created when we first made our project, and this was one of the things that might have shown up when you initially created your project with IntelliJ. Pom.xml, this is a Maven file, and it's describing to Maven what the project properties are. So like the base package name, the artifact ID, the name of the project that you have, the version of the project that you have. It also describes things like the language level that we're going to be using, but the POM file can also be used to describe dependencies of the project. I'm going to add a tag to this file now. I'm going to put an open angle bracket, and the thing that I want to add is the one that shows up first here, dependencies. This section of my POM file is going to list all of the other libraries that my code depends on. Maven is going to go and download these libraries for us and set everything up such that I don't have to figure out how to do things like add to the class path when I'm compiling my code. And if you've ever done that, has anybody ever done that before? A couple of you have. You know it's painful. It's awful to have to do that. Having Maven do this for us is it's wonderful. It's delightful. And I wish I could share the pain that I've felt with Java with you, but I don't want to put you through that. I'm going to pop back over to the Guava website. So just in case you are not taking a look at the web page for today's lecture, the website that I'm looking at here is just guava.dev, Guava.dev. Guava.dev helpfully lists what we need to copy and paste into our POM file here. So I'm going to take this. We are not developing for Android, so I'm not going to include this version. We're using the JRE or the JDK, so we're going to use this version in what I paste there. So I'm going to copy and paste this. I'm going to switch back to IntelliJ. I'm going to paste this in. And I'm going to delete the Android thing. We're not using Android, so we don't need to have the Android dependency. I'm going to save this. And then I'm going to do one last thing. Just give me a quick thumbs up or hands up if right now this is red on your screen, the version. Okay, awesome. I've already done this before class because I wanted to make sure I could actually show you, because I'm going to ask you all to download this thing all at the same time. And the last time I did that, it was a terrible mistake. So what we'll do here is we're going to right click on this. So I'm just going to right click somewhere in the XML file. I'm going to go down to the bottom here to the Maven option. And what I'm going to select here is sync project. This is going to cause Maven and IntelliJ to go through and download that dependency. And so what you should be seeing, and I would like to see a quick thumbs up here, it's not red anymore. Good, I'm seeing lots of thumbs up, awesome. Okay, so now we have added this dependency to our project. And one way that we can see this is if you click on this external libraries here on the left side of your screen, you can actually see that it's gone and it's downloaded a bunch of Guava things, which is awesome because Guava itself, that one jar file, has its own dependencies. And now we've gone through and we've added all of that to our project. Okay, so this is step one. I want to add this dependency, and now you can demonstrate to me that you are able to add dependencies to your project. The next thing that I want to do is I want to start actually making this class invariant in code. Class invariants for us, for this course, I am telling you that it must be this way. We're going to write a private method in our class. I want to strongly say here now, this is a private method. Nobody should be able to ask me to validate myself. I am going to validate myself as a promise to you that what I give back to you is valid. I'm going to validate myself as a promise to you that when I mutate myself because you called this method, that I am still valid. But you should not know how to call validate on me. You shouldn't be able to ask that question of me. So we're going to write private methods for this. And we're going to be using this private method as a precondition. And so what I want to say about precondition here is that a precondition is effectively requiring that assumptions about our inputs or our internal state are met. And for us, for now, that basically means these are things that happen at the beginning of a method. I'm going to call this private method at the beginning of a method as a precondition, and a postcondition is a promise that when I return from this method, I am still valid. I promise I'm still valid. And I'm also going to further promise that if I return something to you, that thing will also be a valid thing. But really, for us, for today, what this means is I'm going to put this before the return statement in my code. So I'm going to hop back to IntelliJ now. I'm going to open up Trainer. I'm going to actually go to Pokemon. I think that's the one that we did together. That is the one that we did together. So I want to add that here. Here is my implementation of Pokemon that has all the properties that we had in that initial definition. Its return type is void. It doesn't return anything. It's just going to do all the assertions for me. It's going to check all these assertions. I'm going to call this check Pokemon. I'm using the word check here again because while we are coincidentally overlapping with some input validation, we're not really validating input here. We're checking the internal state of the Pokemon instance that we're looking at right now. There are two methods that I want us to be able to use. I'm going to quickly switch back to the Guava documentation just to point at what I am thinking about here. This is what I'm looking for, preconditions. The preconditions class is the one that we're going to be using. There are a variety of methods that we can call on this. I want to raise these to your attention, but I'm going to focus on two today. The two that I really want to focus on are check not null, does as it implies. We want to make sure that the thing that's being passed to this is in fact not null, and then print an appropriate message and raise an exception when it makes sense to do that. And the other one is I want to check state. We could do this all with check state because it just takes a Boolean expression, but I want to use the appropriate thing here for what we're doing for this class invariant. So I'm going to head back to IntelliJ here. And what I'm going to start doing is I'm going to start encoding the assumptions that we've made about these types. So I'm going to say preconditions dot check not null. And what I want to pass to that is nickname. And the message I'm going to say here is nickname should not be null. It should never be null. I'm going to say preconditions dot check state. And I'm going to say that nickname dot size length is greater than or equal to 1. Nickname should have at least 1 character or 1 symbol. I'm going to put these on separate lines just so that we can all see them together. Say preconditions dot check state, check not null, type, Pokemon type should never be null. I'm not going to type all these out because that's going to quickly get awkward and painful for both of us. I will type these out after class, and I will share this with you after class. Check the rest. The one thing that I do want to check, though, is the list of Pokemon conditions, because I want to assert to you that that is something that I believe we should check. And so the way that I want to check that, check the rest, and I want to make sure that I'm saying here, including that condition is not null. I don't want to get to this loop checking the values of conditions for not null. I don't want to get to that point if conditions is null. I don't want to get to that point. I want to stop if conditions itself is null. So the way that I'm going to do this is I'm basically going to say for Pokemon condition in conditions, this dot conditions, I want to say preconditions dot check not null, condition, individual conditions should never be null. Okay. So here is my partially complete class invariant for Pokemon. I'm going to add these other properties after class. I will put them on the Git repository. You can pull this if you want to have the updated version of what I'm doing here. But I do have this loop that's going through and checking that every single thing in that list, assuming that it is not null, are also not null valued here. Now I actually want to use this class invariant. And the way that I'm going to do that is anytime you, all of you, and me can interact with an instance of this class, so creating it with a constructor or making changes with mutators, I need to guarantee that my thing is still in a valid state. I want to check everything about it to make sure that I am still in a valid state. The first place that that can happen is up here in my constructor. After I have finished initializing my Pokemon, I should call my class invariant. This is now what I would consider to be a post condition for my constructor. The thing that I've constructed is valid. And so I'm going to say here, check Pokemon. This instance is in a valid state. As a post condition of my constructor, I must have a valid Pokemon. I'm going to scroll down just a little bit. I'm going to say that as a precondition, one precondition, this instance of Pokemon, and I want to emphasize that this is not P. This is not the argument that I am accepting as input here. I'm talking about just me, just me. This instance of Pokemon, not P, with lots of asterisks around it. One precondition is that this instance of Pokemon must be valid before starting this. So I'm going to say check Pokemon here as a precondition. As a postcondition, I'm going to say check Pokemon. One postcondition. This instance of Pokemon, again, not P, must be valid just before returning from the mutator.
We're specifying that this is not used because that would violate the responsibility principle.
The whole idea of design by contract for us here is that I want to check myself. P is another instance of this thing, and so interactions with that class should validate themselves. It feels a little awkward because Pokemon is a type of Pokemon. We're talking about the same class type here. But in other cases where we have different classes showing up in these arguments, I can't ask that question about this other thing. And so what I actually want to do here is, I believe that you're identifying a problem. I believe you're identifying a problem, which is if I just keep attacking this Pokemon over and over and over and over again, it's going to, whoops. As a precondition to this, one precondition. Again, I want to come back to these methods and add more preconditions about what we're doing here. One precondition of this is we are still a valid instance. This is still a valid instance. So check Pokemon. And then just before returning, one postcondition, this is still a valid instance. Check Pokemon. And what I'm going to do here is I'm going to go up, and I'm no longer going to interact with this private property of that class. Again, I know this is the same kind of class, but I'm going to call a method to do this. I want to ask that other Pokemon to do this to itself. And so the way that I'm going to do that is I'm going to say change health, and I'm going to say by -1. That means that when I change the health of that Pokemon, it's going to have the responsibility of making sure that we have met this postcondition. This still has an issue, and the issue here is effectively that while we have these pre and post conditions, they're still going to fail if I constantly attack this Pokemon. And this is now telling us that I need to have a conditional statement here. I do actually have to have this logic here to prevent me from getting into an invalid state. So very, very quickly, I'm going to pop up to my main methods. I've got two Pokemon here, and what I'm going to say is that while true, this is a really vicious attack. While true, Bulbasaur dot attack Squirtle. Just forever. And what we're going to see when I run this, okay, thank you, IntelliJ. Yeah, no, this is not reachable anymore because we have an infinite loop. I'm going to hit play on this. And what we're going to see about this is that we're going to fail one of these assertions. we're going to fail a bunch of assertions because our constructor doesn't actually set anything up, which is actually kind of awesome because it means that we've messed up in our constructor and we haven't set all the properties. What this is telling us now is that just after initializing our Pokemon, nickname was still null, which is not a valid state for our object to be in. And so that tells us that we need to go back to our constructor and start setting those properties and start accepting as input to our constructor. All right, so what we've got now, and I will update this again after class to start putting some of this in and to continue with the conditions that we've got. What we've got now is a class invariant, and we are able to say that we're able to define the properties that we want to have in a class invariant for a type. We're able to call that class invariant using preconditions and postconditions. Again, emphasis here is precondition is just at the beginning, postcondition is just at the end for now, and you should be able to add a dependency to your projects. That's it for today. I hope you have a great rest of your day, and I will see you all on Friday. Bye, everyone.